Hi, Honors Chem students. This video is about how to figure out the limiting reactant when you have two reactant amounts given to you. So we have problems where the limiting reactant is identified. They tell you that one of the reactants is excess, and so the other reactant has to be the limiting reactant. However, we also have problems where we're given two reactant amounts, and then we have to figure out which of these reactants is the limiting reactant. So I'm going to go through these general steps to figure out the limiting reactant. And there are many ways to figure out the limiting reactant, but students seem to find this a difficult concept, and I hope that working through this video will help you learn how to identify it in a straightforward way. So in this reaction, we have the salt-making reaction. 2Na plus 1Cl2 gives 2 NaCl. And we're given 1.5 moles of Na and 0.8 moles of Cl2, and we got to figure out which one of these is the limiting reactant. So what we want to do is first pick one of the reactant moles. Does not matter which one you pick. So I'm just going to pick, I don't know, I'll pick the 1.5 moles of Na. And I'm going to figure out how many moles of the other reactant is needed to react all of this Na away. And for that, I'll use the ratio in the balanced reaction, which allows us to go from moles to moles. Remember, these coefficients here, okay, allow us to go from moles of one thing to moles of another thing, okay? Whenever we're changing between moles of one substance to moles of another substance in the reaction, we use the ratios that are given by the coefficients. So I just pick one of these reactant moles. I'll just pick the 1.5 moles of Na, and I'm going to use my ratio between Na and Cl2, between the two reactants, to figure out, okay, if I want to use up all of this Na, how much Cl2 would I need? Well, I'm going to Cl2, so I'm going to put my 1 Cl2 on top, my 2 Na on the bottom. That will cancel out my Na, and I'll end up with 1.5 times a half. That gives me 0.75 moles of Cl2. So then, after I figure out, okay, this is how much is needed, okay, to react all the Na that we have, okay? These amounts that we're given in the problem, these are what we actually have. All right, so step 2 is to actually compare what is needed to what we actually have. So you can see that we need 0.75 moles of Cl2. And guess what? We have 0.8 moles of Cl2. We've got more than 0.75, right? Have more Cl2 than we need. When that happens, okay, when we have more Cl2 than we need, that means Cl2 is the excess, right? We have plenty of Cl2 to react all of this Na away. So the Na will get used up first, and that means that the Cl2 is the excess and the Na is the limiting reactant. Okay, so we've identified which one's the excess, which one is the Na. Now, like I said, I could have picked either of these reactant moles. I could have picked this 0.8 moles of Cl2, then my ratio would have been the other way, right? I could have picked this and figured out how much Na do I need to react all my Cl2 away. In this case, I would put 2 Na over 1 Cl2, and I would end up with 1.6 moles of Na needed, okay, to react all of the Cl2. And then if we look over and see what we have 1.5 moles of Na, right? We need 1.6. We don't have enough. So this would be our limiting reactant, just like before, right? Na is the limiting reactant, and Cl2 is the excess. It does not matter which one of these reactant moles we pick to figure out this amount needed of the other one. We can do that from either mole amount, okay? And then the second step is to compare to what you actually have in the reaction. Okay, so it's now time to try this practice example number 1 and see if you understand how to identify the limiting reactant and the excess reactant. In this problem, we have our water-making reaction, and you have 2.5 moles of H2 and 2.5 moles of O2. So pause the video, give this a try. Okay, so our first step, we are going to pick an amount, okay, a mole amount, and find what is needed of the other. Okay, so I will just randomly pick this 2.5 moles of H2, and I will find the moles of the O2, of the other reactant. So the ratio is 1 to 2, so 1O2 over 2H2. And I take 2.5 times a half, and I get 1.25 moles of O2. That is what is needed to react all of the moles of H2. Now we're going to compare this to what we actually have. Okay, so we have 2.5 moles of O2. We need 1.25 moles of O2. So we have more than we need. Okay, we have more O2 than we need. This means that O2 is in excess, right? We have more than we need, and so the H2 is our limiting reactant. Okay, so we have more O2 than we need. O2 must be in excess, and H2 is the limiting reactant. Okay, so for practice example number 2, we've got our ammonia making reaction here. And it says, given this balanced reaction, identify the limiting reactant and the excess reactant when you have 10.0 grams of H2 and 40.0 grams of N2. Pause the video here and give this a try. Okay, hopefully you are not fooled by the fact that these are in grams. To use the balanced reaction, we have to compare it using moles, right? We have to have moles, and then we can use the mole ratio to go between moles of one thing to another. So first step is, before you go and apply the process that we did in the previous slides, we've got to change these gram amounts into moles by using the molar mass of these substances. So 10 grams divided by 2.02 is going to give us 4.95 moles of H2. Over here are 40.0 grams of N2, going to divide by 28.02 grams per mole. And if you don't know where these molar masses are coming from, make sure you ask your teacher. This is 1.43 moles of N2. So now I can go back and apply my process, right? Choose one mole amount, pick an amount. Okay, find how much of the other is needed. All right, so I'm going to take my 4.95. I just randomly chose that, okay? 4.95 moles of H2. I'm going to figure out how much N2 I would get in terms of moles using my mole ratio So I would get 1 N2 for every 3 H2. And I can take 4.95 divided by 3 to get 1.65 moles of N2 needed. Look at what we have. We have, okay, compare those. We have 1.43 moles of N2. We need 1.65 moles of N2. We need more than we have. Therefore, N2 is the limiting reactant, and H2 is in excess. So I hope this video was helpful, and you should review these examples. If they still don't make sense, make sure you ask your chemistry teacher.